Welcome to our channel Learning Math. In this video, we're going to solve an orthonormal system question for official exam 2019. As you see, we have in an orthonormal system of axes x prime or x, y prime or y the points A, B and E of given coordinates in addition to a straight line D of equation y equal minus x plus 6. Now we will plot the points A, B and E and then prove that the 2 points A and B belong to the straight line D. Let's start together. We have sure A 3, 3. We should project on x-axis then y-axis. We plot the point A, B 6, 0 and the point E of coordinates 0, minus 6. Now let's prove that the 2 points A and B are 2 points on the straight line D. Since they are asking us about 2 points that should be on this straight line, we can solve it by 2 methods. First, we can find the equation of the straight line AB, which will be the same as the equation of the straight line D. In this case, we can say they are the same straight line. Second, we can prove that each of these 2 points is a point on the straight line D. Let's solve in both ways. We have 4dy equal minus x plus 6. Are the coordinates of A and B satisfying this relation? Minus xa plus 6, isn't xa 3? So minus 3 plus 6 equals 3. Isn't it the same as ya? So we can say that ya equals minus xa plus 6. So the coordinates of A satisfy this equation. What about B? Minus xb plus 6. xb is 6. So minus 6 plus 6, isn't it 0? Isn't it the same as yb? So here we can say that the coordinates of both points A and B satisfy the equation of D, then D is passing through A and B. By the second method, we can find the equation of the straight line AB using y minus ya over x minus xa equals yb minus ya over xb minus xa. In this way, we can find the equation of AB. We have the coordinates given. We can just replace them. Now 0 minus 3 is minus 3 over 6 minus 3 is 3. We can simplify 3 over 3 is 1, so it's minus 1. Then y minus 3 over x minus 3 equals minus 1. Now we just move x minus 3 to the other side, divided by becomes times. So y minus 3 equals minus 1 into x minus 3. Now we just expand the minus times plus minus 1 times x, and minus times minus plus 1 times 3, 3. Now we just move minus 3 to the other side of the equation. Sure, minus becomes plus. We can say in this case y equals minus x plus 3 plus 3, which is plus 6. So y equals minus x plus 6. The equation of D is also y equal minus x plus 6. Aren't they having the same equation? Then we can say here we have the same straight line. So D is the same straight line as AB, then it's passing through the points A and B. We can only use this method when we want to prove 2 points on the straight line. Now let's plot the straight line D. Here we don't need to find particular points. We have just proved that D is passing through the points A and B. We can just join them to get the straight line D. Now D intersects y prime or y at F. Determine the coordinates of F, then verify that A is the midpoint of BF. D cuts y prime or y at F. Can't we say that F is a point on y prime or y? Isn't it at the 0 level relative to x prime or x? So we can say that xf equals 0 since f belongs to y prime or y. Something else, F, isn't it a point on the straight line D? So we can say that the coordinates of F satisfy the equation of D. In this case, we can write it directly. F belongs to y prime or y, x, F equals 0. Also, the coordinates of F satisfy the equation of D. We replace y by yf and x by xf. Now we just replace xf by its value, which is 0, to find yf, which is 6. Then the coordinates of F are 0, 6. We have now the coordinates of B, F, and A. How to prove that A is the midpoint of BF? If we find the coordinates of the midpoint of the segment BF, they should be the same as the coordinates of A. Let's see together. XB plus XF over 2. Isn't it 6 plus 0 over 2? So 6 over 2, 3. Isn't it the same as XA? XA is also 3. What about YB plus YF over 2? Isn't it 6 over 2 means 3? 3 is the same as YA. So we can say that the coordinates of the midpoint are the same as the coordinates of A. Therefore, A is the midpoint of the segment BF. Now verify that the equation of the straight line AE is y equal 3x minus 6. Something very important here, we should just find the equation. If our answer is correct, it will be y equal 3x minus 6. We have several methods to find the equation. We can either use the rule y minus ya over x minus xa equals ye minus ya over xe minus xa. We have the coordinates, we just replace them by their values and solve. Here minus 6 minus 3, isn't it minus 9? Over 0 minus 3 is minus 3. Now we can simplify minus over minus plus 9 over 3, 3. So y minus 3 over x minus 3 equals 3. Now if we move x minus 3 to the other side, shouldn't divided by become times? So y minus 3 equals 3 into x minus 3. Why we put parentheses? 3 should be multiplied by x and by minus 3, not only by x. So we should put x minus 3, we have two terms, we put them between parentheses to multiply both of them by 3. Now we just expand 3 times x, 3x, and 3 times 3 is 9, so y minus 3 equals 3x minus 9. Well, we want to find y to get the equation, so we move minus 3 to the other side of the equation, sure minus becomes plus. Then y equals 3x, minus 9 plus 3, opposite signs, we subtract and put the sign for the greatest, so it's minus 6. Then y equals 3x minus 6, same as it's required in the question. So our answer is correct. Another method to find the equation of the straight line AE, we can start by the slope of AE, which is YE minus YA over XE minus XA. So we started, as you see, by the general form of the equation for AE, y equals AX plus B. Here we find the slope of AE by replacing the coordinates in their values. The slope will be 3. Now we just replace A, the slope, by 3 to find B. To find B, we need a particular point. It can be A or E. Both give the same answer. Then we can say the coordinates of A here, since we are using A, the coordinates of A satisfy the equation of AE. Now we replace Y by YA and X by XA. So YA equals 3XA plus B. We just replace them by their values to get 3 equals 3 times 3, which is 9, plus B. To find B, we move 9 to the other side, plus 9 becomes minus 9. So B equals 3 minus 9 equals minus 6, as you see the same equation. Sure, we are talking about the same straight line. The line AE intersects x prime OX at the point C to 0. What does C represent for the triangle EBF? Something very important. In this case, we should start by the straight line AE. What is it representing in the triangle EBF? Why? Let's join them first. AE and the triangle BEF. What does C represent in this triangle? First, we start by the line AE. As you see, E is a vertex in triangle BEF. From E to A, aren't we having a median from the vertex to the midpoint of the side facing it? Here we have just proved that A is the midpoint of BF. We can say we have here this first median. Something else, if you know that OF equals 6 and OE equals 6, aren't they equal? So O is also the midpoint of EF. Here we have the second median. If we think about it, we are having two medians intersecting at the point C. Then C is the centroid or center of gravity for the triangle BEF. The lines CF and BE intersect at M. Prove that M is the midpoint of BE. This is very important. First of all, we should think about CF and BE, what do they represent? Then we understand what does M represent for it. If we join CF, isn't it issued from the vertex F and passing through the centroid C of this triangle? We have just proved that C is the centroid or center of gravity for triangle BEF. Now the third line, which is passing through this point issued from the vertex, isn't it the third median? Then it will cut BE exactly at its midpoint M. Now prove that the angles OBS salient and OBE salient are each equal to 45 degrees. Let's note something. If you note that triangle BEF is right isosceles at B, we have two methods to prove that these angles are each equal to 45 degrees. First of all, we should prove that this angle is equal to 90 degrees. Well, we have the equation of the straight line D. We can say the slope of D is -1. Since we don't have any number, then x is the same as 1x. So it's -1x, the slope is -1. If we find the slope of this line and multiply the two slopes, we can prove that they are perpendicular. Now what's the slope of the straight line BE? Isn't it YE minus YB over XE minus XB? Now we just replace them by their values. As you see, we get -6 over -6, which is 1. Now multiply the slopes. 1 times -1. Isn't it equal to -1? So we can say that the two lines AB and BE are perpendicular to each other. Here we have proved them perpendicular. First method, we can say that in a right triangle, the median BO is equal to half the hypotenuse EF. Then we can have that BO equals OF and also equal to OE. If you know something, we have the axes X prime OX and Y prime OY are perpendicular to each other. Can't we say that we will get two right isosceles triangles? Then what should be the values of these angles? Aren't they equal to 45 degrees each in addition to these ones? Well, we can also use another method. We have just proved that it's a right triangle. If we find the length of BF and the length of BE, they will be equal. This triangle BEF is right isosceles at B. Since it's isosceles, then the median will be at the same bisector to this angle. It cuts it into two equal parts. Each will be equal to 45 degrees. You can use any way you want. Well, here we have just proved them. So we have said that it's right isosceles triangle, each of them you can use any way you want. Now the parallel through C to the straight line EB intersects FB at K. This is very important. Keep in mind, parallel in orthonormal system, same slope. Intersect, we have to find the coordinates of the intersection. Now let's understand something. Show that the triangle CKB is right isosceles of vertex K. Look at the figure, please. We have just proved that this is a right triangle. These two lines are perpendicular to each other. Now let's draw the parallel. As you see, the parallel to BE through the point C. We have just drawn it. It cuts the line BF at the point K. We have perpendicular. When we have parallel, the perpendicular to the first line will be perpendicular to the second. So here we can say that since they are parallel, D is perpendicular to BE, then the straight line D is also perpendicular to the straight line passing through C, which is CK. Well, here we have found an angle 90 degrees, but we have just proved that this angle is also 45 degrees. Can't we say then that triangle CKB is right isosceles at K? This is very important. First of all, we have to find also something else, which is deduce that CK is equal for 2 radical 2. We can prove it by two methods. We have the coordinates of C, which are 2, 0. We can find the coordinates of K and find the length of CK. This is the first method. And the second method, we have just proved that it's a right isosceles triangle. then the hypotenuse will be equal to side times radical 2 using Pythagoras theorem. Well, let's solve it. First of all, the equation of CK, which is parallel to BE and passing through the point C. Parallel, same slope, then the slope of CK will be 1, the same as the slope of BE. We can write it. After finding the slope, we should find B using the particular point. So we start by the general form of an equation here. The general form for CK is y equal AX plus B. We have them parallel. So same slope. Slope of CK equals the slope of BE equals 1. Here we can just replace A by 1, then CK has the equation y equals x plus B. Particular point, we have the coordinates of C, so we use C is belonging to the straight line. CK is coordinates, satisfy the equation, so yc equals xc plus B. Now we just replace them, we will get that B equals minus 2. So the equation of CK is y equal x minus 2. After finding the equation, we have the equations of the two lines. We can find the point of intersection. K belongs to D, we have the equation of D, and K belongs to CK, we have just found the equation of CK. We can solve them using y equal y. The coordinates of K satisfy both equations of D and CK. We are talking about the same point, so yk equals yk. Then we can write xk minus 2 is equal to minus xk plus 6. We solve this equation to get the abscissa of k. We move it, minus becomes a plus, xk plus xk equals plus 6. We copy it. Minus 2 becomes plus 2, so it's 8. Now 2xk equals 8, so xk equals 8 over 2 equals 4. If we replace it by any one of these two equations, we will get yk equals 2. Then the coordinates of k are 4, 2. Now we can find the length of CK, which will be 2 radical 2 using CK equals radical xk minus xc square plus yk minus yc square. We have the coordinates of both of them. We just replace them and solve. Something else, as I told you, we have right isosceles triangle. We can use hypotenuse equals side times radical 2. We can find the length of CB. We have the coordinates of C and B. Or we can say that CB is 2 over 3 CO. Since C is the centroid, we can find CB by any method we want. Here we have found it using radical xb minus xc square plus yb minus yc square. Well, the hypotenuse is 4, which is equal also to side times radical 2. If we apply Pythagoras theorem for right isosceles triangles, we can find the length of the sides. So CB equals CK times radical 2. Now we just replace them. We move radical 2 to the other side. Times becomes divided by. So CK equals 4 over radical 2. We have radical in the denominator. So we rationalize. We multiply by radical 2 on both the denominator and the numerator. Then it's 4 radical 2 over 2. We can simplify 4 by 2 to get it 2 radical 2. As you see, the same answer. Now how to find the ratio of FC over FM. C is the centroid and FM is the median. Can't we say that FC over FM equals 2 over 3? Or you can find the coordinates of M, which is the midpoint of BE. Then we can say that we find the length of FM and FC. Then we get the ratio, which will be also 2 over 3. Thank you for watching. If you enjoyed this video, please like, share and subscribe.